Hello and welcome everyone to today's ICMA online program titled Recycling Reimagined, Overcoming Today's Challenges. I'd like to introduce our speakers for today, Richard and Pete. Richard Copeland joined Republic Services in 2015 as Vice President of Municipal Sales. He currently leads the $3 billion municipal market vertical for Republic Services by providing leadership, strategic guidance, and support for more than 2,700 municipal partner cities. Pete Keller is responsible for defining and implementing the strategic direction of the sustainability platform for Republic Services to meet business development objectives and customer needs. This includes recycling infrastructure department, functional standardization and optimization, return analysis, policy and procedure development and support, as well as development of renewable energy products, implementation of sustainability initiatives, and customer solutions that support the organization's strategy. Now, without further ado, I'd like to turn the floor over to our first speaker for today. Richard, if you're ready, it is all yours.
Thank you, Emily. And thank you to everyone who's joining us today on the webinar. We look forward to sharing our insights with you and hopefully some great dialogue through Q&A on the tail end of today's discussion. A little bit of scene setting for how the time will go as we move forward. Pete's going to share with us a fair amount of level setting our understanding of what's been happening in the recycling industry, specifically items like the evolving ton, our recycling life cycle, which hopefully will be fairly insightful to municipal folks that are on the phone, trends in our markets, as well as in packaging and the stream overall, and then the impacts that those changes that have occurred over the past couple decades are having, not only on providers of recycling services, but just from the business model overall. I'll be sharing a little bit in terms of approaches that we're looking at as ways to establish a more durable, long-term recycling model going forward. And then we'll share a little bit more with you on the back end in terms of more information and some locations that we'd encourage folks to visit to continue to participate in this dialogue. But before we get rolling, I'd like to establish a little bit of a sense for where folks in the audience sit. So Emily, I'd like to raise the first polling question, if you don't mind.
Absolutely. And for our members in our audience today, you will notice that I am about to bring up a poll onto your screen. Now, this poll is asking, what is most important to your comprehensive planning for your municipality? So we have predictability of rates is one answer, maximum recycling participation, durable programs, or lowest cost. So again, for our attendees, you will notice little radio buttons next to each of these options. Go ahead and select the radio button that best applies to you and click the submit button at the bottom to register it. And we'll just give our attendees a couple more moments to wrap up their responses. And as these responses are finishing out, it looks like about 17% of our attendees are saying predictability of rates. We have 35 or now 36% saying maximum recycling participation, 17% saying durable programs, and 26% saying lowest cost.
Okay, great. So thank you, everyone, for that first interaction. And with that, I'm going to introduce Pete Keller and let Pete take us through a little bit of our insights on what's been going on in the industry thus far.
Thanks, Richard. Good morning, good afternoon, everyone. Thanks for joining. First slide that you're seeing on your screen is what we call the evolving ton. You're looking at 43 years of actual US EPA data in 7 years of extrapolated data that we've prepared ourselves internally. 2013 is the most current year of EPA data, so the last 7 years in this slide are data that we've extrapolated. So you can see over to the far right, estimated compounded annual growth rates in each of the respective segments, organics, waste to energy, recycling, landfill. For those of you that have been in the industry for some time, 1993 was the year that we would characterize the modern-day landfill regulations. Subtitle D was promulgated. That's when we begin to see a spread in waste disposition from traditional landfill to other forms of recycling and/or diversion. In 1993, there were approximately 9,500 landfills in the U.S. Today, there are just fewer than 2,100. So Subtitle D caused a lot of the smaller, rural, often city and county-owned sites to close, and the traditional landfill model transitioned into more of a regional, larger model. One of the very interesting things in this slide, and something that's often lost on folks, there are, on an absolute basis, more tons disposed in 1990 than in 2013. Disposition is really a function of two variables, population and per capita generation, or per capita consumption. Both per capita consumption and population have grown over the course of the last 25 years, and you can see that in the total waste generation. I think we've gone from somewhere around 150 million upwards of 250 million. All of that growth, all of it, has been captured by diversion and/or recycling programs. So from a sustainability perspective, and being the lead sustainability person for my organization, feel very good about the progress that we've made as a nation. Obviously, still some work to do, but the evolving ton slide for us, or the evolving ton data for us, really forms the basis of our investment thesis in and around diversion programs and investment in recycling and diversion infrastructure as we move forward. The highlighted areas, again, to the far right, compounded annual growth, we believe that organics and traditional recycling are growing or will grow at a pace greater than the rest of the traditional lines of business that we participate in. So there's a lot going on this slide. We call this the recycling life cycle. I had mentioned per capita generation or consumption. Obviously, all materials that we end up managing are the result of a consumer transaction. Our customers, whether they're municipalities, homeowners, commercial establishments, contract with folks like us and others to provide certain services. In this life cycle, relative to traditional recycling materials, obviously the customer would place recyclables in a container or cart. We would deploy collection vehicles to collect that material, aggregate that material within a route, process that material in a recycling center or a material recovery facility. One of the things that we like to point out, there's a lot of good intention out there, and our customers are often trying to do the right thing, but the right materials don't always end up in the right containers. So as a result, through our processing facilities, we do incur non-recyclable materials, what we would call residual waste. Those materials are cast out of the life cycle, if you will, and are sent for disposal. The materials that we do capture in our recycling centers, we then resell into markets. I mean, really the intent of any good recycling program is to return valuable materials back into the production cycle. So the majority of what we make and sell, we refer to as bulk grades. Think old newsprint, old corrugated cardboard, mixed paper, various resins, ferrous, non-ferrous, metals, glass, and the like. Those materials are then reintroduced into production cycles, often, cardboard to cardboard, bottle to bottle, aluminum beverage container to beverage container. A lot of the materials are cycled back into the streams from which they came. Another important note in this life cycle is that there is yield loss in production. Anytime that you're dealing with a recovered material, it won't be as clean or homogeneous as virgin materials, and there's yield loss in those production cycles. A big portion of what we make and sell is fiber, so the various paper grades that I had mentioned. Fiber has finite life. Every time that it is pulped, and pulping is largely a mechanical process, every time that is pulped, the length of the fiber is broken down. Generally speaking, fiber can be recycled somewhere in the neighborhood of 6 to 7 times. If you had a bale that was 100% clean fiber, and if you were only able to turn it 6 or 7 times, you're losing somewhere in the mid-teen percentage on average through the pulping process. And that loss just goes through the filters as a sludge. It's just loss. It's not, it has no mechanical strength in paper making. So I think it's important for the audience to recognize that a ton of a particular grade of recovered material does not equate to a ton of finished product through production cycles. Some of the things that drive costs in the recycling life cycle, obviously participation rates at the curb. While a particular municipality or city may have mandatory recycling service, that does not mean that 100% of the carts would be out on every collection day. Obviously, if there's higher participation rates, we would see higher recycling rates within a community. Pounds per set out is also an important variable. Demographics play heavily into this. We have some communities where we would experience 3 to 4 pounds per set out. We have some communities where we experience north of 20 pounds per set out. So some pretty significant variability in the amount of material that folks are putting in their bins on a weekly basis. Commodity mix, we'll spend a lot of time on mix as we move forward through the conversation here today. Material streams change. They change over time. Sometimes they change rapidly. So understanding what's in the material, the percentage of those various fractions in the material, and changes to, the composition of those materials is a very important factor in considering costs. Residual contamination, I had mentioned that a lot of folks, while they have great intention, may be putting inappropriate or unacceptable materials in their recycling carts. That has a huge impact on the model and the cost structure of the business. Not only would you be incurring the cost to collect that material, process that material, you then lose the process capacity that you could otherwise use on good and valuable recyclable material, but then you incur the additional cost to transfer, transport, and dispose of that material at landfill. So you get this compounding negative effect whenever there's contamination in a recycling stream. You also run the risk of cross-contaminating good recyclables with non-recyclables. And then lastly, I've used the word commodity on several occasions. As I'm sure all folks on the line realize, commodities are subject to volatility. By definition, they trade on the open market, and future value is not always known. So those are some of the major items that that impact costs through our recycling life cycle.
So a couple of interesting points for the municipal leaders and city managers on the phone. The education and awareness of the community in terms of what is and isn't recyclable and how to participate in the program that occurs up at the consumption and recycling part of this chart has a pretty large impact, as Pete hit on the residual waste in the bottom of this life cycle, as well as the contamination and the effects it can have on a good load of clean commodity. The other key thing that I hope folks will understand, and the reason that you're reading so much in the industry today about recycling is the original business model was based upon a strong linkage between the cost for collection and the potential to recoup revenue through the resale of those commodities. So in essence, the pricing that many of you see at the curb per resident is subsidized in the original model by the resale of commodities because, many years ago, it was a completely different game. And as we go through the rest of the charts today, I think you'll start to understand that the dynamics have shifted and that current approach that many folks come to market with is driving a lot of the stress that you see in the industry as you read articles out there. Okay?
So, Richard, before you jump, another theme that I would introduce here, and particularly as it relates to the feedback on our first polling question, I think everybody is likely familiar with weight-based recycling goals. I think the polling question came back hot on maximizing recycling rates. A new concept that's beginning to emerge is something that's known as sustainable materials management, and that's really an attempt to look at the embedded energy or maybe even moreover the greenhouse gas implications of recycling a ton of aluminum versus a ton of steel versus a ton of cardboard. And really trying to get at environmental benefit of recycling programs and recycling activity as opposed to just chasing weight. It's emerging. There are a few states in the western U.S., California and Oregon specifically, that are probably a little bit out in front of the rest of the country. EPA is spending a considerable amount of time on it as well. But I think that's something that the audience will begin to see and hear more of over the coming years, really looking at environmental and economic benefit as opposed to just weight-based goals.
Okay.
So just some high-level trends in markets. I had just mentioned the difference difference that can occur in recycling different fractions of the stream. I'm sure that this is not a surprise to everyone. Recycling glass has particular challenges. In most markets, glass has negative value, particularly when it's produced in single-stream recycling facilities. Glass is dense. Therefore, it can't be transported very far. Generally, glass needs to go through some sort of secondary process to color sort it to get it ready for furnace. That's generally referred to as furnace-ready cullet. So there's a lot of additional downstream costs that are required to get glass back into end markets. Glass is something that can be turned over almost forever. There really is no limit to the number of times that it can be recycled. And in markets where there is secondary processing and there is bottle manufacturing or insulation manufacturing, it can make great sense. In other markets where all of those things don't align, the economics of glass can become questionable or challenging. Maybe I should use the word challenging. And it's just important for everyone to understand that that is an important consideration when putting together a recycling program. If there are questionable economics and questionable environmental benefit, then we probably should be having a conversation about what would be included in a good program as opposed to not included in a program. The chart on the upper right is a look at what has happened to the value of OCC, or old corrugated containers, more commonly known as cardboard, over the last 5 years. So we've seen, as an industry, a 40% decline in value over the course of the last 5 years. We really, historically, again, commodity values can be volatile. They go up, they go down. Everybody recognizes that. Historically, we have never seen 5 straight years of declining values. So value proposition that we are experiencing in the markets today is really unprecedented, at least over the course of the last 25 to 30 years. The chart at the bottom, we generally get a lot of interest. The dark blue line is our actual 10-year commodity average, so all things sold, all grades sold. The light blue line is West Texas Intermediate crude. I think everybody can appreciate that there's a pretty tight correlation between those two data sets. Oil has a tendency to influence all other commodities. U.S. currency is also pegged to oil, so the rest of the commodity complex has a tendency to drift with the value of oil. We don't like to say that the past is going to be any kind of indicator of the future, but with this type of correlation and various estimates on where oil will be in 3 to 5 years, we're suggesting that we're, at least from a commodity value standpoint, we're at a new normal. I don't expect to see, certainly not 2008 value levels, and I don't expect to see 2010 and 2011 value levels anytime soon.
So just to circle back on a comment I made earlier with regard to the classic recycling business model from the life cycle on the previous chart, the collection costs that most communities see at the curb is subsidized by the ability to sell those commodities on the back end and recoup costs. That was the original premise of what was set up a few decades ago. And as Pete alludes, we've not only seen declines, but we've seen long-term sustained declines over a long period of time, 4 or 5 years. And when a lot of capital investment decisions are made to build facilities based on sometimes 10-year averages, that the culmination of those is without a doubt what's driving a lot of what many of you see as you read through the industry magazines and articles today.
Yeah, another thing I would add, and again, for those of you that have been in the industry for some time, a lot of the early collection models were based on source-separated materials, the old trough trucks, sometimes dual-stream programs, where less processing was required to bring those materials to market. The vast majority, particularly urban areas of the U.S., are now single-stream. And single-stream is much more efficient, is a much more efficient means of collecting material. We get much higher participation rates, but we also incur higher processing costs on the back end to separate those materials into marketable products. So to Richard's point, the early models that the business was based on have changed.
So That gives us a nice feel for some of the trends that have happened in the markets around us. I think now we'll take a look at what some of the changes over the past decade have been in materials and how they relate to the recyclability and the ability to process.
So I had mentioned that material streams change over time. Sometimes they change rapidly, sometimes they change more slowly. I often tell this story. The first time I saw an iPad was 2009. At least in my mind, 2009 was not that long ago. But I think it's fairly safe to say that the newsprint industry in North America has largely been disrupted. The implication of the data on the right, so newsprint circulation is way down. Subscriptions, at least for print, are way down. In the year 2000, there were 18 million tons of what is known as newsprint furnish, or just think clean newsprint, purchased by printers in the U.S. So that is newsprint on rolls that publishers purchased. In 2015, there were 2 million tons purchased. So significant downturn in demand, significant downturn in production, and certainly that impacts not only the materials that we see in the streams that we receive, but also impacts the demand and value of those materials as we move them through our facilities. All of the newsprint manufacturers in the United States have either gone bankrupt or have converted their machines to other types of paper products. I think there's 2 newsprint mills in all of North America left in operation, and they're both in Canada. So, the takeaway here is that the shift to digital has put pressure on the traditional recycling streams. And Richard had made the point a few minutes ago about capital and capital intensity and investment. A large portion of the investments that we had historically made in our recycling centers was to capture newsprint. So while that equipment still exists, it isn't doing the work that it was originally designed or intended to do. So pretty significant change in material stream happened relatively quickly.
Yeah, and on the relatively quickly point, hopefully folks can realize the average municipal contract for recycling services is somewhere in the 5 to 10 year span. And if you think about Pete's comment that from 2009 when he saw an iPad to 15, that dramatic disruption of that particular stream, a lot can change around us in terms of materials and what's being processed just within the lifespan of a typical municipal contract.
So just some additional information around trends in material. I think everybody's familiar with the detergent bottle. The bottle on the left is high-density polyethylene. It's got some pretty decent weight to it when it's empty. We refer to that grade as HDE pigment. It's highly recyclable. It's highly marketable. It's easy to process. Literally just rolls out of the paper when we run it through our recycling facilities. That packaging, while it still exists, is evolving. I think most folks are probably familiar with the package to the right. That does not contain liquid detergent. It contains the pods, the drop-in pods. That container is made of PET, the same resin that water bottles are made of. And while PET is highly recyclable, orange PET is not. It is recyclable, but it is very difficult to aggregate at individual locations, store, and then ship to market in full truckloads. There are only a few buyers in the world for that type of resin, and it makes it very, very difficult, frankly uneconomical to recycle. So while the product is recyclable, it is not recycled. So we think it's important just to note that there can be a lot of confusion. Certainly the folks that make this container fully intend for it to be recyclable, but it is not finding its way back into market. This container has actually evolved again. It's not uncommon to now see those pods sold in Ziploc bags. I probably shouldn't say Ziploc out loud, but sold in flexible plastic bags. Again, that is a package that is particularly difficult to process, separate, aggregate, and then market. Then lastly, on packaging, this is probably not a package that is specific to, let's say, soup. We now see sour cream, applesauce, all manner of other, let's say tuna, chicken, all manner of other food products delivered in what is known as a copolymer or a retort pouch. These pouches have multiple types of resin. They often have a foil layer. They are very lightweight, so they behave like paper when we attempt to process them. Very difficult to recycle because of the materials that they're made of. I would say from a sustainability standpoint, it's a very efficient package. It uses very little resources. It is virtually weightless, shipped empty. It is flat, and literally millions of those things can go on a truckload. Much more efficient package from manufacturing to the shelf. So while the sustainability of that package is great, it is very difficult to recycle. And it can be a considerable fraction of the contamination that we incur at our facilities.
So I think a couple of key points in the past few charts for everyone is that the material does continue to evolve, and it will continue to evolve as technology comes forward and as manufacturers continue to innovate how they want to differentiate their brands and bring products to market. And the impact that those changes has on the need to educate the public on what they should and shouldn't be putting into their recycling containers, as well as for folks like us to keep up our technology in our processing facilities with the ability to source, separate, and aggregate that material. Those changes drive costs that typically hadn't been recognized in the early days of the original business model.
So this is just a look over the last 25 years of what's been occurring with material outputs. So this isn't materials that are recycled. These are materials that are manufactured and purchased through consumer transactions. We've already spent some time talking about newspaper. That's the bar all the way to the left, so that's probably not a surprise to most on the line. Similarly, we've seen a shift away from what I would characterize as heavier containers, glass and steel, and we've seen a shift towards lighter containers, particularly plastic. So, it wasn't that many years ago that mayonnaise and peanut butter and the like all was in glass jars. Those products are sold almost exclusively in plastic jars now. I guess I would say that all is not bad. We've also seen a huge increase in corrugated containers or cardboard. We generally refer to that as the Amazon effect, but 5-10 years ago, we really didn't see a lot of cardboard in our residential streams. Cardboard was generally captured through all of our commercial accounts and commercial businesses, but we're seeing a lot of cardboard in residential streams today, almost exclusively driven by online shopping. So just some additional thoughts on lightweighting. This is a pretty telling graphic. I think everybody's familiar with the water bottle and how light they've gotten, how much product has been engineered out of the container. In 2000, it was approximately 48,000 plastic bottles to make 1 ton. Last year, not quite a doubling, but 92,000 plastic bottles per ton. And remember, back to the life cycle and the evolving ton graphic, disposition or generation is really driven by the consumer transaction. So whereas 15 years ago, roughly 48,000 consumer transactions made a ton, it's quite a bit more than that now. So when we focus on weight-based recycling goals, and maybe we've heard over the course of the last 3 years that recycling rates have stagnated, there's probably a perspective out there that would say, on a percentage basis, it has, but we're capturing more of the consumer transactions than we've ever captured before. So the important point here is that processing material is really volume-based, and creating value from that material is weight-based. So if we have a recycling facility, let's just say for purposes of this graphic, that was developed in 2000, and it had these types of materials, these water bottles, in fact, moving through it, and it was rated at the time at 30 tons an hour. Today, that same equipment moving this lighter material would be rated at 15 tons an hour. So just because the materials that we're processing are getting lighter doesn't mean we get to turn the system up to stay at 30 tons an hour. So when you go from 30 to 15, your processing costs on a unit basis double. Now that's just a simple example of what the impacts of lightweighting can be on an operating or in an operating scenario.
So for everybody that's wondering how much more flimsy the water bottles will get, they already don't stand up on your desk. The good news is they probably can't get much lighter because the way they're engineered is to allow them to be stacked in a pallet in the back of a tractor trailer. If you put one more case on top of that pallet, the bottom would rupture. And so the good news is you probably can't do a lot more to wring out material from the manufacturer's side, but the impact on the lightweighting is pretty evident from this graphic, and it's pretty telling for those of us that are in a weight-based business model.
And if you could harken back to the life cycle slide, I talked a little bit about yield loss in production. Some of these bottles now, the caps actually weigh more than the bottle. The caps are a different resin. They're high-density polyethylene, the bottle's PET. We sell those recovered bottles to various manufacturers that are interested in the PET. So it's not uncommon to have a bale of PET that's almost 50% polyethylene because most of the bottles have caps on them. We always recommend to our customers to leave the caps on. It's the only way to capture them through the life cycle. The folks that we sell PET to have processes in place that allow them to capture the caps and reintroduce that polyethylene into various end markets. but it is a function of yield loss and inefficiency that's directly related to package design. So we talked a little bit about the importance of public education. We recognize that there can be a lot of confusion out there in the marketplaces, and we recognize that there is some confusion community to community. It isn't always the case where all of the acceptable material lists are identical, and sometimes we even see cities that are contiguous to one another have different acceptable lists of materials. These are just some common examples of what we see in terms of contamination. We see a lot of yard waste, a lot of expanded polystyrene, which is virtually impossible to capture in modern state-of-the-art recycling facilities. There's a lot of confusion around pizza boxes. Are they recyclable? Are they not recyclable? The term that we always use is empty, clean, dry. I think any recyclable material, regardless of its intended use, is recyclable so long as it is empty, clean, dry. If we get a pizza box that's full of pizza, we run the risk of contaminating other good, clean material that we would have otherwise been able to market. Lots of food contamination, and then one of the things that causes the most trouble for us is textiles or clothing. Have a tendency to get in our equipment, get wrapped around our equipment, and can really foul up our processing. One other thing that we've begun to see more and more of, and it's particularly troubling, is medical waste, or specifically sharps. A lot of folks have a tendency to save sharps at home in 2-liter soda bottles, and then when those soda bottles are full, somehow they make their way into the recycling streams. Those soda bottles don't always stay intact through the collection process and then through the recycling center, so that can cause some real problems, not only for the materials that we're trying to make, but most importantly, the safety of our employees.
So, going back to our earlier discussion, the impacts of public education, or a lack of understanding and an appreciation by the public in terms of what to do, it can lead to, the term is aspirational recycling, where they're not quite certain, so they'll hope that it is recyclable, they'll throw it into the container, and what they're actually doing is driving two things: either contamination, as Pete hit on, where you can take a good ton of commodity and have it damaged or contaminated, which brings the value or the willingness for someone to buy that commodity significantly down, or even it could be rejected. And then the other are just items put in the container that flat out are not recyclable, and we call that residual, back to the life cycle. And we then have to continue to incur costs to aggregate, separate that residual, and then transport it to a landfill and dispose of it properly. And so many times the effect of education on those two elements, contamination and residual, are not, they change over the life of a contract and can significantly hurt a provider's ability to continue to serve in a way that's good business for both parties.
So there's many examples of education. This is a graphic of what we call an in-mold label. So this would actually go on top of a cart, and it's embedded or melted into the lid. We've done a lot of research in and around this label. I'm not sure how well everyone can see it. It's bilingual. It's a color graphic. Our research suggests that folks learn in various ways, and pictures help reinforce what is acceptable. Our research also suggests that we should not have pictures in and around things that are unacceptable. This is not intended to blanket the U.S. We have various versions of this because we recognize that markets are different and the availability of end markets in certain parts of the country are different. But we believe this can be a very effective tool in helping ensure that we get more good recyclables in our streams and less unacceptable materials.